Good evening, guys. It's Cameron here again with another video. This time we're going to teach you how to solve for the current of your loop and junction rules using the matrix method. So the first key that you're going to want to start off with here is write down your junction rule, which I've got here. This is my junction rule. And then your two loop rules that you use, this one and this one, okay? It's important to write it in this order too, just for simplicity's sake. I think that writing it like this is definitely something that makes it easier, especially when it comes to plugging it into our matrix. Additionally, you can see our values from our circuit here. We've got the value of our three resistors, and then the voltage drops across both of our power sources, both of our batteries. And that's important too because you can see that these values obviously correspond to the respective values in the equation. So E2 would get plugged in for E2 here, right? Okay. So the first step that you're going to want to do for this, see I've got these arrows here, is that for this first step, you're going to want to get all of the currents on the same side of the equation, just like I have here. So all I did was I subtracted I1 from this side and brought it over here, and that equals 0, and that's what we want. That's good. These two are set up already the way that they're supposed to be. Normally when you write your loop rules, everything will be on one side and it will be equal to 0, but our instructor did us a favor here and he already put our voltage drop on the other side of the equation, and that's helpful for setting up our matrix later. So we want it in this format here, where the currents and the resistances equal the voltage drop for each equation. And you can see over here, all I did was that I plugged in our variables, I plugged in our resistances and our voltage drops into here. You're not going to plug anything in for I1, I2, or I3 because those are what we'll be solving for eventually. All we need to do is plug in the resistances. So R1 goes here, R2 goes here, our voltage drop goes here for each one, right? Great job. Okay. The next step, and this might be the most complicated, just to get down at first, is our matrix method. So let me just give a little roundabout presentation of what this is. So we've got three different matrices here. This one's going to be a 3 by 3 matrix. This is going to be a 3 by 1 matrix and is the matrix we are solving for. So we don't have to do anything for that. We can leave that as is. And then B is going to be our 3 by 1 matrix that uses these three values here, 0, 5, and 25. So we can go ahead and write those in just as they are, just like this. So we've got 0, 5, and 25. And you can put your units if you'd like. It doesn't necessarily matter. So cool, we've already filled out one matrix. This one is a little bit harder to do, so what I've done is I've tried to simplify it by labeling each of the columns and the rows. So the columns will be labeled I1, I2, and I3, and the rows will be labeled 1, 2, and 3 in reference to our three equations that we have here. So let's go ahead and plug these in. So in our first equation, is there a resistance that corresponds to I1? Let's go up to our equation 1. Oh, I'm sorry, I skipped a step here. Since our first equation is our junction rule, we're only going to use ones and negative ones. So this positive I2 corresponds to positive 1, this I3 corresponds to positive I1 as well, and this I1 corresponds to negative 1. Sorry if I confused you there. So let me just write this down and hopefully it'll make a little more sense. So our I1 is negative 1, our I2 is positive 1, and our I3 is positive 1. My equation's a little bit out of order, but you can see that the value for I1 is negative in this equation, and it's negative for I1 in my matrix as well. I2 and I3 are both positive, so I2 and I3 are positive 1 here. This is the only time we're going to draw ones and negative ones in our matrix calculation. For equation 2, if we go up here, like I said, we're looking for something in equation 2, some resistance in equation 2 that corresponds to I1. So if we go up to our equation here, here's I1, and it's got 75 ohms attached to it. And that's the only I1 I see in here. So let's go ahead and plug 75 in for our second part of our matrix here, 75. Cool. So let's go to I2 now. Is there a part in equation 2 that has a resistance attached to an I2 current? And yes, there is. 5.6 ohms is attached to I2. So we go to our I2 column for our second equation, and we write in 5.6 ohms. Okay, now it's time for I3 in our second equation. Let's go up to our second equation here. There's I1, there's I2. I don't see an I3 in this equation right here, so all we're going to do for that, we're just going to pop a fat little 0 right in there. So let's go ahead and practice filling out our third row, just like we filled out the previous two. Start with I1. In the third equation, let's find the resistance that corresponds to I1. I don't see any, do you? All I see is I2 and I3. So we're going to put 0 right in there, okay? Now for I2, we're going to look up and find the resistance that corresponds to I2, and it's 5.6. So we're going to go ahead and plug 5.6 in there again. And our last one is I3, and that's 122. Boom. So now you can see our matrix is completely set up. We have our A matrix, we have our C matrix. Watch how I label these because it's kind of important, but it's mainly for simplicity's sake. And then our B matrix. Great job. Okay. The next step that we're going to want to do is pull out our trusty calculator. Follow these directions pretty closely too, because sometimes you can get lost in the TIs. Here's how we attach our matrix here. I'm going to set this up nice and nice, I guess. So turn your calculator on. And if you'll notice in your calculator, there's a yellow line that says matrix. That stands for matrix. And here's how we get there. You're going to click second, this yellow button, go to matrix, boom. And that brings up this little menu here. And we can see the names of our matrices here, and we can see how big they are too. What we're going to do is we're going to scroll over, push in this button here to edit, and we're going to go edit our first matrix. We can see that it's already a 3x3, and it allows us to plug that in up here. So we can go ahead and just double check that 3x3. Excellent. Now it's going to let us plug our values in. Just fill out the table in there, just like you would fill it out here. So we've got -1, and then +1, and then another +1, just like our top row there. Then we have 75, 5.6, and 0. And for our last row, we've got 0, 5.6, and 122. Boom! So this matrix is done. Now let's go back to our matrix menu by pressing second and matrix. And let's edit our third matrix here. Notice that I haven't done anything with matrix C. We are not going to do anything with matrix C. It is just there for us to visualize, okay? So we're going to go down to matrix B. Notice I've labeled this one matrix B. Very clever, right? And we're going to edit that. And we want to make sure it's a 3x1 matrix. And we're just going to plug it in just like we see it here. 0, 5, and 25. 0, 5, 25. Additionally, it is important to remember that your signs must be the same as they are in your equations. And if you'll pay attention, if you've been paying attention in this video, you'll realize I've made a mistake here. So for my third equation, I2's value is supposed to be negative because it's negative in the equation. I didn't reflect that here, so I'm going to go ahead and do that right now. I2's value should be negative. And what I'm going to do is I'm going to go back to my first matrix, and I'm just going to change the value of that 5.6 to reflect that it's a negative 5.6. Good catch, guys. Great catch there. Cool. Now that we have our matrices set up, we are all done. We just have to solve. So here's how we do it. Press second and go to matrix, but instead of going over to the edit, we're just going to select our first matrix. We're going to click enter here. So now we've got A. Then here's what we do. Times, whoops, sorry, go back. We want to do the inverse. A inverse, or the inverse of A, times, go back to matrix, go to matrix B, boom. And those should be our current answers. The sign also reflects the direction of the current, so make sure you include that in your final answer. Thanks for sticking around, guys. If you have any questions, please drop them in the comments section. I'll be sure to get there and answer them as best I can. Good luck studying, guys, and hope you nail this test. All right, have a good night.